7 women, you had 10 women. But once you had 3 men and 7 women, you couldn't say 10 anymore. You couldn't just count how many. Now, if your mind can understand that, then you can't tell me that you can't understand why you cannot add fractions that don't have a common denominator. And people will say, and they'll think it's all right, and they'll say, well, why can't you do that? Why can't you add the 3 and the 2 and add the 4 and the 5? That's like saying you have 4, I don't know, quarters, and 5, let's just say nickels, which it wouldn't be, fifths, and saying you have 5, what, quarter nickels? These are things. You have to recognize that this number does not, the only way this tells you how many is that it tells you how many were in the whole. It represents the whole. It's not what you have. What you have are 3 of them. What they are fourths. What that means is that some whole was cut into 4 pieces evenly, and you have 3 of them. You have these. Here it says something was cut into 5 pieces evenly. And you have 2 of them. Now how do they become ninths? Because a ninth means that something was cut into 9 even pieces. And you have 5 of them. If I took these and laid them here, that's not going to equal this. And that's what you're saying, that they started out being big pieces. You had 3 of them. Then you had 2 of these pieces that were kind of big. Now you're ending up with just 5, but now they're these little bitty pieces. If you have 3/4 and 2/5, you can't add them together by counting 3 and 2 and saying you have 5 anything. You have to find out something that they can both turn into. Something that they both can change to. Like we said, a dime can change to nickels, and a nickel is a nickel. So then we can change them all to nickels and say we have 3 nickels if we had a dime and a nickel, you see. If you had a quarter and a dime, however, you can change that quarter and all dimes. You see what I mean? You'd have to change that quarter and the dime into nickels. Or change them all into pennies. You see what I mean? To make them all the same. Once something is cut, the only thing you can do is keep cutting it, making the pieces smaller. Once I have it in fourths already, the only thing I can do is take each piece and cut it again, make each piece now 2 pieces. Now they're still even. Where I used to have 1, now I have 2, like when I change a dime into nickels. Same amount of money, just different size pieces, you see. Now these are what? They're eighths, right? Or I could take each one of those fourths. Now it's already cut, I can't change that. I can cut each one into 3 pieces evenly. Then how many pieces would be in the whole? If you had 4 pieces and I cut each piece into 3 pieces, how many pieces
12.
would be in the whole? Huh?
12.
12, right? 3, 6, 9, 12. Or if I took each piece, I can cut it into 4 pieces. Now how many pieces would be in the whole?
16.
16, right? Or I can take each piece and cut it into 5 pieces. And now how many pieces would be in the whole?
20.
20. Do you get what I'm saying? Once it's already cut, the only thing you can do now is to cut it in the multiples of that number, because you got 4 pieces. So it's always going to be 4 times however many times you cut it, right? It's going to be the multiples of 4. That's why you have to know your multiplication facts, because you have to know what are the multiples of 4. Once it's cut into 4, what else can it be cut into? It can be cut into 8ths, 12ths, 16ths, 20ths, 24ths, 28ths, you see what I mean? You got to know your 4ths. The 5ths, once it's already cut into 5 pieces, all you can do now is cut it in each piece into 2 pieces, each piece into 3 pieces, each piece into 4 pieces, the multiples of 5. So now instead of having 5 pieces of cake, you're going to have 10 pieces. Same cake. You're not getting any more cake, you're just getting more pieces. You see what I mean? If you got $1, I don't care if you got 100 pennies, you can have 100 of them, you still just got $1. You guys ever heard that story or read that story? I know I read the story to my kids when they were young, and I think it was a Shel Silverstein. Teresa, do you remember who wrote that? But it started out, this little kid in the morning, it was his birthday, and he got some money for his birthday. He may have gotten like, I don't know, let's say he got a $5 bill or whatever. And so he was all excited, and he went to school, and all along the way, or anyway, all that day he kept trading it. And he traded the $5 for like $2. He had 2 $1 bills. Well, he said, oh gosh, my dad's gonna be so proud of me. I started out with 1, now I have 2. By the end of the day, he had about 10 or so, but they were all pennies. So he went from a $5 bill to 10 pennies. You see what I mean? You can have a whole lot of something, but depends on what they are, is what makes the value. If you came up to me and said, how much money do you have? And I said, oh, I have 50. 50 what? You see what I mean? 50 just tells you how many. That's the numerator. Every number has a denominator. We just don't have to see it, because when we do whole numbers, we have place value. We are in the base 10. And we learn that, and so forth that way, and it keeps going that way. But we know this tells us that we have 2 what? 2 what? 2 10s. This is 21, we know that. We know that we have 2 10s and a 1. You see what I mean? We know what that 2 stands for in the 1. In whole numbers, because it's place value. Because in our whole number system, every place is a power of 10. So we don't have to tell you. It's automatic if it's there. Because if the 2 is there, how many do we have? 200s. So you knew that automatically. So every number has to have a place value, because the number itself just tells you how many. It's what they are that tells you how much, you see. When you go to the bank with a check, and you have a check for $100, and the teller will ask you, what denomination do you want it in? See, denomination tells what kind it is, what it is. Because that $100, you can get it in 1 bill, 2 bills, 5 bills, 10 bills, 100 bills. I don't know about you guys, but I know when I was a kid and getting money for my birthday, you know, and some of the good uncles would give you a $5 bill. Kids would come, you know, they're going to put $1 in your little card. But those 5s, I'd take them to the store at the corner, and I'd get 5 ones for each one of those 5s, and I'd have a wad of money. And I think I was rich. Well, there was all ones. Guys do that now. They put a wad of ones and stick a 20 on the outside and try to act like they have some money. But yeah, you know, because we think of how many, but it doesn't matter how many, it matters what they are. You know, if I got 50 $100 bills, that may be a lot of money. 50 pennies, not so much. You see, $51 bill is better than 50 pennies. You could have 50 dimes. So just 50 doesn't mean anything. Again, in our whole number system, the denominator we know because of the place value. But everything is not divided into tens and hundreds and thousands. That's why you have to have common fractions, because some things like a week is divided into 7. Okay? But again, when you have to add them, and you can have that. You could have 3 pieces of something that was cut into 4 pieces, and you got 1 piece of something that was cut into 7 pieces. But I want to count them all together. I got to find something I can cut a 7 into and a 4 into. So that means I have to think of what are the multiples. Because once it's a 7th, it's not getting any bigger. You can't make that piece any bigger. All you can do to that 7th is cut it again and again and again. You can get that picture? See, all you can do is cut it down smaller. You can't glue anything to it and make it bigger. So I have to say, what can I cut this into? And I can cut these fourths into the same size, then I can add them all together. And what would that number be? 28. 28 is the first number that I can cut a 7 into and also a 4 into. So I'm going to change them into 28s. Now to cut a 7th, it was a 7th. I want to cut it into a 28th. I want to make sure there are 28 pieces in the whole. That means there are going to be the same number of pieces in each one of these 7 pieces. How many pieces does each one now have to be? 4, right? So that when I cut them all, each 7th is now going to be 4,